It just says they're inverses of an exponential. So like we did exponential growth, exponential decay, the logarithm is the inverse of that. Like we would convert between log form and exponential form. So I'm just going to show you this real quick, how to do this by hand. So this will work for any log function. It says find the inverse of the logarithmic or log function. And when we find inverses, all we're going to do is we're going to switch x and y. So I'm just going to write x equals log base 3 of y, like that. And I'm going to use the tables here in a second. But if I get rid of the log, to get rid of the log, we convert this to an exponential, right? So the base of the log swings over to the other side and pushes that 3 up in the air into being an exponent. That gets rid of the logarithm. So it'd be 3 to the x equals y. All right, so I know I kind of cheated ahead of time and typed that right there, but that's your inverse. That's your inverse. So it's easier to graph an exponential. Logs, you can't do different bases on the calculator. Well, you can depending on your calculator, but you can always do an exponential. So I just did like a couple negative, couple positive, 0 for my table. So if I did 3 to the negative 2 power, right? That's 1 over 3 squared, which would be 1/9. If I did 3 to the negative 1, be 1 over 3 to the first, so this would be 1/3. Anything to the 0 power is 1, right? So 3 to the 0 is 1. 3 to the first would be 3, and then 3 squared would be 9. So I'm going to go ahead and graph that just on the coordinate plane over here so you guys can see it. And just for these decimals, let's just do our very best to estimate. So negative 2 1/9 would be pretty close to the x-axis. Negative 1 1/3, I'm going to kind of try and eyeball like 1/3 of the way up. The rest of the points will be nice. So I have 0, 1, I have 1 3, and then I have 2 9. So this will be a good review of graphing an exponential here. And then for my exponential function, I'm just going to go ahead and do this on the graph. Remember, that has an asymptote where it gets really close but doesn't touch it, doesn't go over it. So that would be the asymptote for that exponential function. And let's just fill in like the domain and range and stuff over here real quick. So domain, I know it goes gradually, but it does go to the left forever. This goes up really fast, but it does go to the right forever. So the domain of any exponential function should be negative infinity to infinity. Now, the range depends on where your asymptote is at. So I'm not touching any part of the graph till we hop over the x-axis. So remember, this never actually touches 0. It never becomes negative. So when you do the range, it's 0, comma, then it's going up forever to infinity. It's a parenthesis because you don't actually touch 0. And then the asymptote for an exponential function, which is what we graphed there, should be a horizontal asymptote. So it's y equals whatever that number is that you had in the range. This doesn't have any shifting of any kind, so asymptote for any exponential should be horizontal. Now, if you guys remember when we did inverses in our functions unit, literally if I have a table of the inverse, I can just switch the x and y values to graph this log. So this is my inverse here, right? And I'm just going to switch it around. So we would just trade the x and y values. So I already traded the y values for you. So we're just going to trade the x values. So this will look different. And if you remember, inverses are a reflection over the line y equals x, which is the little dotted line that you see in the diagram there. So these, if we folded it in half on this diagonal line, if I graphed it perfectly, it should match up. Okay, now here's the deal with this. When you graph this, my x value is 1/9. So like I'm barely going to go over and then try to put a point down near negative 2. If I go over 1/3, I'm just like barely going over, like just estimating 1/3 of the way, and then go to negative 1. The rest of these 1 0, 3 1, and 9 2. These are all nice points, but when you draw this, you're going to get really close to the y-axis, not touch it, not go over it. So in that case, for the log function, the log, that general shape that you see, is going to get really close to the y-axis. Never touch it, never go over it. It's because you can't take the log of a negative number. Sorry, let me pull that back down so you guys can see a little bit better. But in that case, you're going to have a vertical asymptote. So if I just look at my log graph, all right, my domain here, you're not touching any part of that log graph till you hop over the y-axis, right? So this should be 0, comma, then it goes to the right forever to infinity. And if you guys remember, whenever you have inverses, the range of the original should be the domain of the inverse, and that's the case. And then same thing, the domain of the original is the range of the inverse. So this guy, clearly, that goes down forever. This is going to the side, and it looks like it kind of levels out, but gradually this would go up forever eventually. So the range for any log function should be negative infinity to infinity. And again, it should just be flipped over. The range of the original is the domain of the inverse. The domain of the original is the range of the inverse. The other thing that's different about the log function, asymptote for a log function is going to be a vertical line. That vertical line is preventing me from plugging in an x value that would cause me to take the log of a negative number. So it should be a vertical line. Sorry, forgive. I should have written horizontal on this one. All right, now, so this vertical, I call it vertexal to remind me, it's x equals, and then whatever your asymptote is, in that case, it's the y-axis, which has the equation x equals 0. Is anybody having a question at the moment? Okay, now, I'm going to kind of give you like a general thing for graphing these to hopefully help. And if this helps you anyway, I could also write it as y equals log base b of x. I wrote it in function notation. It is a function that would pass the vertical line test. Okay, now here's the deal. All of these functions, I promise you, have the point 1, 0, and whatever the base is, 1. They always have those 2 points. And let me show you why. Doesn't matter what the base is, let's call it b. I'm going to convert these to exponentials to show you these real quick. So if I plugged in, let's say I plugged in 1 for x to that lovely little formula, I'd have y equals log base b of 1, right? If I convert that to an exponential real quick, b to my y coordinate would be equal to 1. What does y have to be to make this to this power equal 1? What power would y have to be? 0, right? Anything to the 0 power is 1. So that's why if you plug in 1 for x, the y value has to be 0 to make that true. That's why any exponent, doesn't matter what the base is, any exponential function will have that point 1, 0. There's your little proof right there. Okay, now it will also have the point, whatever the base is, 1. Okay, so let me show you this. So I just used b to represent my base, so it's saying I'm going to plug in whatever that base is. I just used a b in place of the x. So that would look like that, y equals log base b of b. Okay, if I swoosh this guy to the other side to get rid of the log, you would have b pushing that y up in the air to be an exponent, so exponential form. B to the y is equal to b. What would y have to be there to make that true? 1. Okay, b to the first would be equal to b to the first. So that's why you have the second point, whatever the base is, and then 1. So what I have graphed here, just to show this to you guys. All right, so, and again, if you want to put like y equals log, this is base 5 of x. I have this graph just to show you guys what this looks like. Okay, so for this one we did up here, this was base 3. So this has the point 1, 0, and 3, 1, right? 1, 0, is that 1, 0, and then the base in this case was 3, and that has the point 1. So this one has the 2 points, 1, 0, and 5, 1. So let me just show you why that works. If I do like y equals log base 5 of 1, right? If I swoosh this over, we'd have 5 to the y equals 1. So then in that case, y would have to be 0. So there's that point right there. If I do y equals log base 5 of 5, and I swoosh this over here to solve this, we'd have 5 to the y equals 5. So then y equals 1. That's where you get those 2 points. Now you're probably like, I mean, there's points in between there if you guys can tell, but they're not nice numbers. They would all be estimated numbers. The next nice number you could get out of that, if I had a log base 5, you would want to think of plugging in numbers that would give you like powers of 5. So if I plugged in like 25, if you swung this over, this would be 5 to the y is equal to 25. Y would then have to be 2. So the next point I could nicely graph there would literally have an x value of 25 and a y value of 2. So it'd be like way over to the side of the graph. So those 2 basic points, that 1, 0, and then whatever the base is, 1, those are probably your best bets in terms of working with that. Is anybody having a question where those points are coming from? Okay. Now, I'm going to have you guys, we're going to shift on the back a little bit. So that's what we're going to work on back here. All right, so you got to remember, and there's a couple ways to do this, but I'm going to try and teach you like the easiest way that I can think of. And I'm going to make sure I'm on the screen maybe. Okay, one thing I do want to remind you. Can't take log of 0, that's not defined. That's your asymptote if you don't have any shifting, or a negative. So we're going to have these vertical asymptotes that are going to prevent us from moving to the left side of wherever that asymptote is, because that'll prevent you from taking the log of a negative number. And the shifting works just like every other graph that we have shifted, okay? The one thing I'm going to have you guys do differently is I would have you kind of, I'm going to shift the axis to show you this, but whatever's inside with the x, this is left or right, and then this is the opposite way you think. So to me, if it's like a -2, or it's like x minus 2, it actually moves it 2 units to the right. It's what sets it equal to 0. And what I would tell you here is this value would be like your new y-axis. Okay, that's what I'm going to write down there. Whatever that h value is. Now, the k, this is up or down, and you would just copy that number, and that's going to be what I would tell you to do, like your new x-axis. So, I've got graphed on the screen, on the graph, is just the one I just showed you on the front, just log base 5 of x, that's on the graph. We're going to shift it. And so here's the easiest way I can tell you to do this. Inside opposite, so this is going to be 3 units to the right. So it looks like a -3, so it's going to go 3 units to the right. What I'm going to do on my graph is I'm actually just going to like make a vertical line at x is 3. Okay, now the +1, let me grab a different color. The +1, this is going to go up 3. So instead of the x-axis where it's at, I'm just going to move the x-axis. I don't know why I just said up 3. Up 1 is what I meant. Up 1. Okay. Now, if you want to do it like this, this is kind of how I do it. I like basically redraw the x-axis and the y-axis. Now, based on that, I should have the point 1, 0, and then whatever your base is, 1, to give you a general shape of the graph. So what I would do over here, just look at those 2 dotted lines that I drew. So the point 1, 0 would be right here. This is actually 4, 1 on my graph. And the other point would be from my pretend x and y axis here. Go over 5, 1, 2, 3, 4, 5, and up 1 is actually the point, whoops, 8, 2 on the graph. Now, if you want to look at that, what it's doing is it's adding 3 to the x coordinate and adding 1 to the y coordinate. So if you looked at this 1, 0, plus 3 would be 4, plus 1 to the 0 would be 1. For the second coordinate, I'm adding 3 to the x, so 5 goes to 8. I'm adding 1 to the y, so 1 goes to 2. You could do it that way too, or I like to just kind of shift the x and y axis. And then we're just going to kind of draw best we can. Try not to go over that vertical asymptote that you drew. and we're just scooching those points over is all we're doing. That's probably the easiest way I can show it to you. And I wanted to put that just y equals log base 5 of x so you can compare. So we're going 3 to the right and up 1 when we shift those points. If you had the points on the graph, which I don't have on the homework, you could literally just do that. Count over 1, 2, 3, up 1. This one, count over 1, 2, 3, up 1. You could do it that way too. I don't have those graphed on the homework assignment though, so I want to practice that way. Okay, now, what we just graphed, the domain, you cannot take the log of a negative number or 0. So if I was on the left side of 3, like if I plugged in 2, we'd be taking the log of a negative number, so that's a problem. So whatever your vertical line is here, that's where your domain should start with a parenthesis. So this would be 3 comma infinity, goes to the right forever. The asymptote is vertical here. That vertical line is preventing me from taking the log of a negative number. So it's a vertexal line, so it should be x equals 3. We're going to get really close to that, never touch it, never go over it. And just so I can write it underneath here, it says underneath this, the range for any of these should be negative infinity to infinity. All right, but part of that goes down forever. This part is going to the right, but it gradually does go up forever. And then I got one more we're going to shift here. Let's see, this guy is log base 5, x plus 2, so this is going to go left 2. So I'm going to take my y-axis and I'm just going to draw a little dotted line left 2 units. That's actually going to be your asymptote too. So I'm trying to prevent myself from taking the log of a negative number. If I would plug in like -3, we'd be taking log of negative number. You can't do that. Your lovely number that's -4 outside here is going to shift down 4. So I would just take the x-axis and I'm going to draw it down at -4. Okay, if you want to think about the original 2 points that we have on here, we have 1, 0, and then we have 5, 1. Okay, so there's kind of 2 ways you can do this. If you want to, you can, left would be to subtract 2 from the x coordinate. So if I'm at 1 for the original, subtract 2 would be -1, down 4 would be -4 for the y coordinate. So it should be -1, -4. If you want to do the other one, it's the base, which is 5 and 1. So left 2 would be to subtract 2, so that should be the point 3. Down 4, 1 minus 4 would be -3. Now, if you don't want to do that, I just use the x and y axis. So like my new x and y axis I created, here's the point 1, 0. And guess what? That's the point -1, -4. And then I'm going to go from my x and y axis I'm going to go 1, 2, 3, 4, 5, 1. That should be the other point, which if you check, this is 3, -3. So there's a couple ways you can do that. If you want to just use like the new x and y axis and use those 2 points, or if you want to convert them, it's up to you. But what this should do is take that graph I've got there, we're going left 2, down 4. Now again, the domain just prevents you from taking the log of a negative number. So if I plug anything smaller than -2, we're taking the log of negative number. If I plug in -2, we're taking the log of 0. That's not okay either. So that's why this is a parenthesis and not a bracket. So any number -2 or bigger is good to go to plug in. The asymptote there should just match with whatever you did to go left or right. So this went to the left 2, so it should be x equals -2, that vertical asymptote that you drew in. Does anybody have a question? Okay, now let me scooch down to the bottom. Now these guys are base 4. All right, so this is a base 4. So the basic 2 points that you would always have, it's 1, 0, and then whatever the base is, so this is log base 4 and 1. Those would be 2 points that you could easily graph. So if you want to have a shift of any kind like we have here and just move your x and y axis, you can do that. Or if you want to perform whatever we're shifting or whatever to the points, you can do it that way too. It's up to you. I usually just shift the x and y axis. So can anybody describe to me, if I do log base 4 of x minus 4, how's that going to shift the graph? Like left, right, up, down, what am I doing here? This is going to go right 4. Okay, so here's all I would do. I'm going to go over to 4, right? And I'm just going to draw, this is like my new y-axis. Now, I don't have anything added or subtracted, right? There's nothing outside those parentheses. So then the x-axis would just stay where it's at. So if I was graphing those 2 points, 1, 0 would be right here. And then I'm going to go 1, 2, 3, 4, 1 would be right here. And then I'm just drawing that kind of that shape. Kind of trying to imitate that shape. If you want to take and move the points, all right, we would go from 1, 0 and 4, 1. All we would do here is go to the right 4 units. So we would just add 4 to the x coordinate. We wouldn't do anything to the y coordinate. So this would go to 5, 0, and then I'm adding 4. This would go to 8, 1. And you guys can see if you look at my graph, those are the 2 points that are on there. So if you want to kind of do that to the points, or if you want to just do that on the graph, it's up to you. Now this one's tricky. This says log base 4 of x minus 2. What kind of transformation am I making here? Up, down, left, right? Both? This, no parentheses, okay, right? No parentheses, so this is just down 2. All right, so for this one, all right, I'm going to move my lovely x-axis down 2 units. And on this one, we don't move left or right, so the y-axis would stay right where it's at. Now, I usually just use my new x and y axis, and I'm going to plot the point 1, 0, and 1, 2, 3, 4, 1. So all this should do is scooch those 2 points that you guys can see on that parent function that's graphed there for you. It should just scooch everybody down 2 units. If you want to do this with the points, so 1, 0, and 4, 1, what you would do is you just subtract 2 from the y coordinate. So this would still be 1, but then this would be negative 2. This would still be 4, and then this would be negative 1. You're just going to subtract 2 from the y coordinate. The x coordinate wouldn't change there because you don't go left or right. Or you could just do what I did, and you can see those are the points I have. Here's 1, negative 2. Here's 4, negative 1. Oh, forgive. I didn't do the asymptote. Let me do this. So this guy that we just did in the first part would be 4 comma infinity, and x is 4 would be your asymptote. This guy would be 0 comma infinity because we didn't go left or right, and so our asymptote would be x equals 0, which is the y-axis. All these logs have a vertical asymptote, so like vertexal if you want to think about it like that. And then the last one, we're going to move a couple directions here. This is going to go left 1, and then we're going to go up 3. All right, so if I go left 1, x is negative 1 would be my lovely vertical asymptote. I'll just go ahead and put that on here. And my horizontal, we're going to go up 3. So up 3 here. And then I just do those 2 points. Here's 1, 0, and 2, 3, 4, 1 would be here. So if you look at the 2 points that are already on the graph for you, it should shift them left 1 and up 4. Or if you want to do like what I said with the points, like 1, 0, and 4, 1. What you would do for each x coordinate is you'd subtract 1. So this would be 0, this would be 3. And for each y coordinate, you would add 3. So this would be 3, and this would be 4. And if you look at the points on my graph, that's where I'm at. And my domain here, you can't take the log of a negative number. So parentheses, negative 1, any number bigger than negative 1 is going to be okay for us to take the log of. And that's all we're doing today. So basically, just remember those points, 1, 0, and then whatever the base is, 1. Make sure you look at the problem because I think I have different bases for some of the different graphs on the actual homework assignment. But that's what you guys are working on today.